In this video, we're going to discuss Article 110.14b, Splices. This section of the National Electrical Code focuses on how to properly join two or more electrical wires together, known as splicing. It outlines the methods, materials, and safety steps for making splices that are safe, durable, and reliable. Let's break this down into simple terms. First, let's mention why this rule exists in the first place. When you are connecting electrical wires or splicing, you need to ensure that the connection is strong, secure, and safe. A bad splice could result in electrical faults like overheating, short circuits, or even fires. The rule helps prevent such issues by outlining how splices should be done correctly. Let's talk about what this rule covers. The first thing it covers is splicing methods. Splicing devices. When joining wires, you should use splicing devices that are designed for the job. These devices should be labeled or identified as safe and appropriate for the type of splice you are making. This ensures the splice will hold up over time without causing issues like loosening or corrosion. Next, we have brazing, welding, or soldering. You can also join wires by brazing, welding, or soldering them together, but these methods require special care. The key is that the joint must be mechanically and electrically secure before any solder is added. The soldering process. If you're using the solder to join the wires, you should first make sure the splice is mechanically secure without the solder. In other words, the wires should be physically connected in a way that holds them in place firmly, either twisted together or clamped with a connector. After that, solder can be applied to create a good electrical connection. Next up is insulating the splice. After splicing or joining the wires, the spliced connection and any free ends of connectors must be properly covered with insulation. This insulation should be at least as protective as the insulation on the wires themselves. You can use insulating devices like electrical tape, heat shrink tubing, or specifically designed connectors that are made to protect the splice from damage or contact with other parts. For direct burial, if the splice is made on wires that will be buried underground, such as a trench, the splicing device must be specifically listed and rated for direct burial. These devices are built to withstand the elements, moisture, and pressure from the ground. So let's walk through an example. Imagine you are installing outdoor lighting in your garden and you need to connect two electrical wires underground. Here's how this rule applies. You need to splice or join the two wires together. You can't just twist them together and hope for the best. Instead, you need to use a splicing device that is meant for the job, something like a connector that is rated for outdoor use or underground wiring. If you are using soldering, you should first twist the wires together securely and make sure the connection is solid, and then you can apply the solder to make the connection even stronger and ensure good electrical flow. After the splice is made, you should cover the splice with insulation that protects it from moisture and damage. You should use special waterproof connections or heat shrink tubing that will seal the splice and keep it safe for underground use. If you are to bury the splice directly in the ground, the connector you use needs to be listed for direct burial, making it designed to handle the harsh conditions of being buried underground, like moisture and soil pressure. So to sum it all up, Article 110.14b ensures that splices between wires are done correctly to prevent issues like loose connections, overheating, and electrical hazards. It requires that the connection is secure, insulated, and properly done using the right tools and materials. Whether you are splicing, brazing, or using splicing connectors, make sure the connection is mechanically and electrically secure before finalizing it, and that all splices are properly insulated. If the splice is in a location where it will be exposed to moisture or buried underground, special care must be taken to use devices specifically rated for that environment.